Good afternoon, fellow viewers. Welcome back to Easy Mathematics. Thank God today is another day. Today we want to look at finding the mean of a set of data. Finding the mean of a set of data. When we say mean, what is mean? Mean is the sum of the set of data divided by the number of items in the set of data. Mean is the sum. So the words here that we have to keep in mind is mean is the sum of the set of data. So the sum of the set of data divided by the number of the set of data, and that is going to give you the mean. So when you put the sum or when you put the set of data together and you divide it by the number of sets of data, then you are calculating for the mean of the set of data. Now the mean is denoted by this sign, x with dash on top. It is being defined or denoted with this sign. Now we have the first question here, which says that we have to calculate for the mean of the set of data. And from the definition here, mean is the sum. The sum. So to calculate the mean for this set of data, you can say mean, which is denoted as this sign, is equal to the sum of the set of data. So because we are using sum, in terms of formula, we can say sigma x. And this x represents each of the alphabets here, each of the numbers here. So the sum of these values divided by the number. So let's say n. So the sum of the set of data divided by the number, which is n. So when you put the set of data together, then you divide it by the number of items. 1, 2, 3, 4, 5. You divide it by 5. So in finding the mean of this set of data, we are going to say that mean is calculated as the sum. So we are going to put the set of data together, which is 5 plus 2 plus 4 plus 2 plus 5 all over n, and n or divided by n, and n is the what? The number of items. 1, 2, 3, 4, 5. So divided by 5. So put all the numbers there together. We are going to get this plus this is going to give us 7. 7 plus 4 is going to give us 11. 11 plus 2 is 13. 13 plus 5 is going to give us 18. So the sum of the set of data is going to give us 18 divided by 5. Now when you are able to get this, then you divide this using the long division approach. So when you look at this, 5 will go into 18 3 times, leaving a remainder of 6. So leaving your answer in decimal place, we are going to get 3.6. So 5 will go into 18 3 times. Remainder 3. In terms of decimal, we are going to get 0.6. So the mean for this set of data is 3.6. as it has been indicated here. Number 2, we have to find the mean of the set of data. And mean is the sum of the set of data divided by the number of what? Items. So we are going to say that mean is equal to sigma x over n. And sigma x is the sum of the set of data. So 1 plus 2 plus 1 plus 2 plus 3 plus 2 plus 1. All decimal divided by n, which is 1, 2, 3, 4, 5, 6, 7, divided by 7. So put the set of data together. Put everything here together. If you put them together, you are going to get 3, 4, 6, 9, 11, 12. So the set of data put together is going to give us 12 over 7. Then you ask yourself, 7 will go into 12 how many times? You can use your long division to get it in decimal place. So when you look at this carefully, 7 will go into 12 one time. It will go into it once, leaving a remainder of 1. So 7 will go into 12 once. So we are going to get 1 point, and it will be having a remainder of 5. So with this 5, we will bring the point here and it will be 50. So 7 will go into it 1.5 times, leaving behind a certain numbers. But if you round it to one decimal place, you are going to get 1.5. Sorry, 1.7. 1.7. Sorry, because 7 is 49. So you are going to get 1.71. Leaving to one decimal place is going to give you 1.7. So 12 over 7 in decimal is going to give us 1.7. So the mean for this set of data is 1.7. Now let's look at the number 3. We have to find the mean of the set of numbers 2, 3, 2, 4, 4, 5. To calculate for the mean, we have been told that the mean is the sum of the set of data. So first find the sum of the set of data, then you divide it by the number of items. So we can say that the mean, or mean, which is denoted as this, is equal to sigma x over n. And sigma is sum. X represents each of the values here. So the sum of x, we can say this is equal to 2 plus 3 plus 2 plus 4 plus 4 plus 5 all over n. N refers to the number of items, or where n is the number of items. So we are having 1, 2, 3, 4, 5, 6. So over 6. So now put the set of data together. So this plus this is going to give us 5. Plus this is 7. Plus this is 11. Plus this will give us 15. Plus this will give us 20. So the sum of the set of data, we are having 20. All over 6. So with this one, we can do some cancellation by saying that 2 into 6 3 times, 2 into 10, sorry, 2 into 20 10 times. So we are going to get final answer after simplifying 10 over 3. And with this one, we can say that 10 over 3, we can leave it in a decimal form. Anytime you are calculating for mean, you have to leave it in a decimal form. Because sometimes you'll be asked to round it to a given decimal place. So rounding 10 over 3 into decimal place, you are going to get 3.3333333333 continuously. Or we say recurring. So we are going to say our final answer for the mean here is 3.3 as our answer. To one decimal place is 3.3. And this is how we find the mean, or we can calculate for the mean of a set of data. Put the set of data together and divide it by the number of items. Now we want to look at finding the mean of a frequency table. How can we find the mean of a frequency table? With the same thing we have here, the sum of the set of data over the number of items. But when it comes to the frequency table, we use the same definition, but we add a certain things, or we add certain things to it to make certain difference when it comes to the frequency table. We have the first example here, which says that the table below shows the ages of students in KG2 class. Find the mean. So we are going to use this table to find the mean. When it comes to the frequency distribution table, to find the mean, we use a formula which is being stated as sigma fx over sigma f. We use the formula which states that sigma fx over sigma f. So we have to look for sigma f, and we have to look for sigma f, and also look for sigma fx. So if we have these two formulas, we have sigma fx, we have sigma f, therefore we can find for the mean. So how can we calculate the mean of a frequency table? To calculate the mean of a frequency table, we have to know this formula, sigma fx over sigma f. So from this table, we are going to find sigma fx and find sigma f. So what we are going to do is that, looking at the table here, the edges here takes the x value, or they represent the x values. And the number of students shows the frequency. So the edges here is the x, and the number of students here is your f. So we are going to redraw the table again. But this time, we are going to draw it vertically. So we will go by this way. We have our edges here, which is the x, or they are the x values. Then we have the number of students here. And they are the f values, which is the frequency. Then we draw another table here, nicely. So we are going to get 3 sets of tables. So we have this, and this. Now, the ages represent the x values, and the ages are 3, 4, 5, 6. And with each frequencies, we have 3 is having a frequency of 4. 4 is having a frequency of 5. 5 is having a frequency of 3, and 6 is having a frequency of 2. So this the same table here, but we've constructed it in a vertical way. Now, since the edges represent the x values, and the number of students represent the frequency, which is the f values, we are coming to find fx, or we are going to calculate for fx. And fx means f times x. What is f? The number of students. What is x? Ages. So you pick this frequency, then you use it to multiply its corresponding x value. So 4 times 3 will give us 12. That is fx. 5 times 4 will give us 20. 3 times 5 will give us 15. And 6 times 2 will give us 12. Now, if we are able to solve to this position, then we've almost cleared 50% of our problems or burdens. Now, we have f here, and we have fx here. And to calculate for the mean, we need sigma fx and sigma f. In our previous video, when we were talking about the median, we were told that the sigma means sum of. So the sigma fx here means sum of the fx, and these are the fx values. So we are coming to look for sigma fx, which says put everything here together. Then these are the f values, and this is going to give us sigma f, and also says that put the values here together. So when you come to the frequency column, if you put all these things together, what are we going to get? We have 4, 5, 3, 2. Putting everything together here, we are going to get 14 as our answer. So sigma f is equal to 14, and sigma fx, sum of fx. So you are going to put everything here together. So let's do it vertically. 2 plus 0, 2, 7, 9. So we have 9 here. Then 1 plus 3, 2 giving us 3, 4, 5. And this will give us 59. So now we have our sigma fx as 59 and sigma f as 14. Now with this, we can now calculate for the mean of the frequency table. The mean is given as this formula: sigma fx over sigma f. From the frequency table that we've constructed, sigma fx is 59, so we are going to say 59 over sigma f. Sigma f is what? 14. And this is equal to, we are going to use the long division approach to get our answer. So you can see clearly that using our frequency table, we've been able to arrive at the mean of the frequency table. Now, 14 divided by 59. Let's use the long division approach and see what we can get. Looking at this carefully, we can say that 14 will go into 59 4 times, and it will leave a remainder behind. So 14 will go into 59 4 times. 4 times 14 is going to give us 56. 14 times 4 is going to give us 56. And when you do your subtraction here, you are going to get 3. Because 14 cannot divide 3, we bring a point here, we have our 0 here. And now we can say that 14 can go into 30 2 times. So 2 here, 2 times 14, or 14 times 2 is 28. 28, if we take 28 away from 30, we have 2. Because there's a decimal point here already, we bring 0. We have 1, 14, 6, so on and so forth. So to one decimal place, the mean for this frequency table is 4.2. And this is how we calculate the mean of a frequency distribution table. Now let's look at the second question, where we have another table and we have to calculate the mean. Now this question is saying that the table below shows the scores obtained by some students in a test. Find the mean. The table below shows the scores obtained by some students in a test. Find the mean. Now, because we are finding, or we are coming to calculate for the mean, we have to first construct our own frequency table. Now, anytime we are being given a question like this and the numbers are already in a table form, we say that the data has been grouped. So how can we therefore construct our frequency table? The frequency table will be constructed vertically. So we are going to get or have our scores here. And these scores represent the X values. Then we have number of students. And this also represents the F values. So we have our table this way, nicely drawn. Then we will add another table, making it 3. So we have the scores here, the number of students, then this gives us Fx. So the scores are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have it there nicely. Then you draw your table nicely with a ruler so that your work will be neat for the examiner to mark it clear for you to get your full marks. Then you construct a last one where you do your segments. So this is the table that I was given, and before I can calculate for my mean, I have to redraw my own table and add only the Fx column. So what I have added here, or what we are going to add, is only the column for the Fx. And the first value here represents the X values, and the second one here represents the frequency values. Because when we say frequency, it's simply the number of items or individuals. So with the 1, we have 2, 2 is 3, 3 is 2, 4, 1, 5 is 0, 6 is 2, 7 is 3, 8 is 4, 5, and finally 2. So these are the X values, F values, then your Fx. And Fx is F times X. So this is F, this is its corresponding X, F corresponding X, F corresponding X. So you just multiply. So 2 times 1 is going to give us 2. 2 times 3, 6. 3 to 6. 4, 1, 4. 5 times 0 is 0. 6 times 2 is 12. 7 times 3 is 21. 8 times 4 is going to give us 32. 8 times 4 is 32. And 9 times 5 is 45. 10 times 2 is 20. So these are the Fx values and these are the F values. And we were told that to calculate the mean is sigma Fx over sigma F. So we have to find sigma F, that is the sum of the frequency, and sigma Fx. So let's put these values together and see what we are going to get. 5, 6, 7, 8, 8, 10, 13, 17, then 17 plus 5 is going to give us 22. 22 plus 2, we are going to get 24. And our value, the sigma F, is 24. Let's try it again. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 24. So sigma F, we have 24. Then we also find sigma fx. So this will give us 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 28. So you are going to write 8, remainder 2. So we have 2, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we are having 148 for our sigma fx. If you put everything here together, you are going to get 1. So sigma fx is going to give us 148. Good. Now that we have our sigma fx and the sigma f, we can find the mean using this formula. Because to calculate for the mean is sigma fx over sigma f. So from our table here, we can say that sigma fx is equal to 148 over sigma f, 24. So with this, we try and cancel out to get our lowest value. So 2 can go into both values. So 2 will go into 24 12 times. 2 will go into 148 74 times. Again, we can use 2 to simplify. 2 will go into 74 37 times, and 2 will go into 12 6 times. Now we are having 37 over 6. Now with this 37 over 6, there is no number that can go into 37 and at the same time go into 6. So we are going to change this into decimals. So we have 6 out, then the 37 in, using our long division sign. 6 will go into 37 6 times. 6 is 36. If you subtract 36 from 37, you have 1. So because 6 cannot go into 1, we bring a point, then this gives us 0, making 10. 6 can now go into 10 once, 6, 1, 6. Then we have here 4 after subtracting. 6 cannot go into 4, but because there is a decimal point here, we can bring 0, which is going to give us 40. 6 can now go into 40 6 times, and 6 is 36. So we can pause here and leave our answer to 1 decimal place. So we are going to get 6.2 as our mean. So we can say that the mean is equal to 6.2. To 2 decimal place, because this is greater than 5, we are going to add 1 to it. And the mean for this table is 6.2. Thank you for staying tuned, and this is Easy Mathematics. God willing, we will be bringing you the latter part in collecting and handling of data. See you next time. Bye-bye.